Hi, this is Richard C. I'm a math tutor at Wyzant, and I'm responding to a question submitted by a student. The problem is asking him to find this definite integral from 0 to 2 of this function, and he's having trouble understanding why the integral does not exist. So the source of this confusion really is just that the student has never thought about what the function looks like. So I think that this is just a good general advice. I mean, if the function is a polynomial or something, you probably don't have to worry about it much. But if it's what's called a rational expression, then you should be going back to your Algebra 2 tools and doing a quick sketch before you try to take the integral. So let's look at the function. It's 1 over 2x minus 3 squared. So we can see right away that there's a vertical asymptote. You just set 2x minus 3 to 0, and so you get 3 halves. There's a vertical asymptote at 3 halves. Because 1 over 0 is undefined, so x is not allowed to be equal to 3 halves. There's also a horizontal asymptote, because as x gets infinitely large or infinitely small, you'll see that this is 0. This ratio comes closer and closer to 0 as x gets very big or very small. If we were to sketch this, we would have a vertical asymptote at 3 halves. And the x-axis is also a horizontal asymptote, so I'll just extend that, which is a good way to indicate it, I think. And you see that this function is always positive because 1 is positive and anything that's squared is positive. And we know the end behavior is to get closer and closer to the x-axis. So this graph is going to look something like this. It's going to be asymptotic this way, asymptotic this way, and it's going to be the same on the other side. And of course, let me just change color here. We're interested in the integral from 0 to 2. So 0, here's 2 here. Let's say that's 2. So we're interested in this space here. And because that includes the vertical asymptote, this function is not continuous in the interval 0 to 2. And if a function is not continuous, it can't be differentiated. And there's no antiderivative. So that's why this does not exist. So I think it's just good general advice to check the graph first before you start doing these things, and especially when you have a ratio like this, because the denominator can never be 0, and that limits the domain of the function. So that's what's going on with this problem. So that mystery's been solved. Okay, I hope that helps, and I'll see you guys next time. Bye-bye.